Hey Mustangs, in this video we're going to take a look at the three different types of selection that we see occurring in nature. So in order to understand the three types of selection, first we have to refresh our memory of the bell curve. Okay, so with the bell curve, it maps out the number of individuals that have a certain variation of a trait, and when we map it out we find that the average of the trait is the most number of individuals, and the extremes of the trait you find less individuals. So if we talk about human height, number of people who are 3 feet, very few. Number of people who are 4 feet versus 5 feet versus 6 feet and 7 feet, 8 feet, and so on. So the number of individuals at the extremes tend to be lower, so very few people actually have the extremes, or individual organisms if we're talking about other species, while there seems to be an average. Now, this makes sense. So if we take a look at this bell curve here, the individuals, the reason why there's more individuals with the average of the trait is because that's the best trait to have. So if you have a really good trait, you're more likely to survive and more likely to reproduce. When you go towards the extremes, the reason why you find less and less as you move away from this ideal version of the trait is because that's not the ideal trait. That's not the great trait, the good trait to have to survive in the environment. So as you move away from that trait, you find less and less individuals because these extremes out here, they're not quite the right traits to survive. Okay? So you find very few individuals that actually show those extremes. All right, we're going to use the finches on the Galapagos Islands to go over the three different types, or at least two of the three different types of selection. So here, this is South America. You got a picture up here. Here's North America. California would be out over here somewhere up towards the top. So these are islands off the coast of South America. The interesting thing about these islands is that while they're close together, they're very close in proximity, they have very different climates and habitats. So on one island you might find deserts. On another island, lush tropical forests. Another island, volcanic rock, so black barren volcanic rock. And so when you look at these islands and you look at the animals that live on them, you notice that from one island to the next, the species vary based on their environment. So you can see that certain individuals have the right traits for that environment. You go to another island and the individuals have a different variation of the trait for that environment. Now these were actually the islands that Darwin himself visited, and this is kind of where one of the places where he had that aha moment of how things can change by natural selection. So if we take a look at the finches, and this is just an example of some of the finches, there's actually many more finches that live on these islands here. But let's say that these finches, this is their common ancestor. Okay, so let's say that. So if this is their common ancestor, so the South American finch, once these islands formed, flew out and started populating these different islands. The birds with these beaks here are found on an island where the best source of food is small insects in holes. So if you can imagine this as the ancestor, if the birds originally look like this, they came to the island, and any birds that had slender, skinnier beaks were more likely to survive. So it didn't instantly just go, okay, slender beaks all survive, everybody else dies off. But over time, generation after generation, any birds with slightly skinnier, longer beaks more likely to survive, until you get to a point where you have birds that look like this. Now this, if we're looking at a bell curve, we find most birds have a beak like this. Some birds might be more towards the extreme, where some birds have really super skinny beaks while others have a little bit thicker beaks, but we'd find that most birds would have this because that's the right variation of the trait to survive. Down here we'll go to the different extreme. These birds' primary source of food are large seeds. So again, starting with an ancestor like this, if you can imagine, any birds that had slightly bigger, hardier beaks, they're more likely to survive and reproduce because they can get the food. Slowly over time, generation after generation, beaks become bigger and bigger and bigger till eventually you get to what we see here today. Okay? So we're going to take this concept and apply it to the three different types of selection. Alright, so in the first type of selection, it's called directional selection. Okay? And directional selection favors the extremes of the trait. Now, when we look at this graph here, this is the original bell curve. So the dotted line is the original bell curve of the population. So if we're looking at beak size, I'm going to draw these in real quick. If we're looking at beak size, okay, so the average, that's what we said most of the individuals have. So I'm just going to draw a medium-sized beak just for visual purposes, okay? The extremes would be smaller beaks, and the extreme over here would be bigger beaks, okay? And in the original environment, having this size beak was the right trait to survive, so most individuals had that. Let's say the environment changes, and in this environmental change, all you have is large, hard beaks. Large, hard seeds. If you have these large, hard seeds, who has the best beak to survive? Well, the ones with the extreme. Now, initially, there's not very many individuals that have that, but slowly over time, because they have the better trait to survive, instead of seeing very few of them, we wind up seeing a lot more of them. Okay? These guys over here, their beaks are so small that they die off. In fact, there's none left with that size. And these ones that were once the large in number and had the best trait, the number of them have decreased down to here. Okay? So the bell curve has shifted. It favored more of the bigger beaks to survive, and we see a shift. So now we see more individuals with the bigger beaks, none with the extremely small beaks, and the once favored medium-sized beak is now less. All right. In stabilizing selection, I'm going to use humans as an example here. In stabilizing selection, when there's conditions that favor the average more than the extremes. Okay? So if we look at the dotted line, that represents the original bell curve. Here we're talking about the size and weight of babies when they're born. Okay? Now, babies born under, let's say, 6.5 pounds, okay, tend to have more medical conditions and are less likely to survive. Babies born over, let's say, 8 pounds can get stuck or cause complications on the way out that can either cause the death of the mom or the death of the baby. Okay? So in this case, stabilizing selection happens. So if this was, let's say, 3 pounds, 4 pounds, 5 pounds, then you get over here towards 6 pounds, 7 pounds, 8 pounds, 9 pounds, and so on as far as baby weight goes. So you imagine it going across here. The average becomes favored, because if you're below a certain weight, it really causes a big, sharp decrease in the chances of survival. If you're above a certain weight, it causes a major decrease in the chances of survival. So in this case, stabilizing selection. You find very few of the extremes and more of the average. All right, last example of selection is disruptive selection. In this case here, it favors the extremes rather than the average. So again, we'll use our finches. So imagine here, in this case, again, the dotted line representing the original population. And let's say the environment changes, and this is an extreme example, but we'll just use it. It kind of helps us paint a mental image here. In an extreme example, you would have, let's say, small seeds and large seeds in this new environmental change. Before, the medium-sized beak was the one you needed to survive. Now in this new environment with small seeds, if I draw the beaks, so small beaks, medium-sized beaks, and the large beaks, having this trait was once good, but now in the new environment, having a smaller beak means you can crack open those smaller seeds easier. If you have a larger beak, you can crack open the large, hard seeds easier. The middle-sized beak, well, they can crack open both, but these guys are more efficient at it. So the smaller and larger beaks are more efficient, so they're more likely to get more food. So over time, you find more and more of them and less of the average. All right, so that is the 3 types of selection. Make sure you write and draw those into your notebook on the correct page.